biofortification, something like genetic manipulation, and finally, after listening to the entire lecture, they say whether it is permitted in India. Okay, so that confusion should not be there. So that is why I'll just take you through a brief introduction about the micronutrient malnutrition, how it is very significant in human health, and what are the approaches to mitigate this micronutrient malnutrition, and how the biofortification will help, because there are already efforts in different crops to biofortify the crops so that the required micronutrients are available through the grains itself. You need not go for any other supplements or other fortified food products. Okay, so let us enter the arena of biofortification. So let me start with the basic food what we eat. Okay, so we all know that our food has to come from the agricultural systems. There is no other way that you can have your food. Everything has to come from agriculture, whether it is plant-based or animal-based. So it is basically the agriculture system. Okay, many people, of course, those who are born and brought up in cities, they don't consider this. Actually, they think, okay, food, they have the choice, so they can take whatever food they want, but everything has to come from the agricultural systems. Okay, so over the years on the development of the agricultural scenario, what has happened is all the agricultural systems, they mostly focus on the increased productivity and profitability for the farmers and the agricultural industries. Okay, so our aim was always to grow more so that there is sufficient food for everyone, and secondly, there is benefit both for the person who grows, that is the farmer at the basic level, and also to the industry which involved in the processing. Okay, so that was our aim for all these years. Okay, so our agricultural systems, or the to be specific, as a breeder, we never concentrated or explicitly designed our breeding programs to enrich the grains. Okay, so we never thought about promoting the human health through food, because our always the aim was to grow more food and more money. Okay, so because we always believe that the health comes from the pharmacy. Okay, if we are not well, just go to the pharmacy and get the required medicine and you can improve your health. So that was our basic concept, right? Sorry, yeah. So according to Food and Agricultural Organization, a human being require 49 known essential nutrients for sustaining the human life. Okay, so they have classified it into the 6 categories. The first one is water and energy. So the water and energy means energy. Of course, you know that the carbohydrates are the source of energy, and water is also classified as a nutrient. Okay, so many of you must be wondering, how can be water is a nutrient? It is a nutrient because in many of the African countries or in many developing countries, clean access to clean drinking water is also a problem. Okay, so water is also considered as a nutrient, because if clean drinking water is not there, then you will not be having the good health which is required to even digest whatever you have eaten. Okay, and the second is the protein, that is which provides the amino acids. So a lot of amino acids are there. So these are the essential amino acids like histidine, isoleucine, leucine, lysine, methionine, etc. Then the third category is the lipids, that is the fat, and the component of fatty acids. And there are many fatty acids, and 2 are most important, that is linoleic acid and linoleic acid. Okay, so mainly many of the nuts and the groundnut is a good source, linoleic acid. Then there are macro elements, that is sodium, potassium, calcium, magnesium, sulfur, phosphorus, and chlorine. Okay, so these are the macro elements. Then there are micro elements. So micro elements are also important. It's not that micro means, okay, they're less important. No, they are also important as much as macro elements. The only thing is that they are required in less quantity. That is why the term micro elements has come. Okay, so the micro elements, there are many, 10 to 12, starting with the iron, zinc, then copper, manganese, iodine, folic acid, etc. Then comes the vitamins. Okay, so in vitamins, there are fat soluble and water soluble. So A, D, E, K. So you know that these are the fat soluble vitamins. Then the C vitamin and the B complex, a variety of thiamine. Then what is it? Niacin, then B6, B9, biotin, B12, etc. So all B vitamins, which are water solubles, they are also important. So these are the 49 essential nutrients required for the good human life. Okay. So the malnutrition, both under as well as overnutrition. Many times the wrong concept is that malnutrition means okay, undernutrition. No, it is not only undernutrition. Even the overnutrition leading to obesity. Nowadays, the major problem in case of urban areas, even in case of rural areas also, wherever the economic prosperity is there. So the overnutrition also leading to obesity. So these are all the both undernutrition as well as overnutrition. These are the result of dysfunctional food systems. Means the food systems are available. You have the access to food system. You have the economic power to purchase the food, but the food cannot supply all the nutrients and health promoting factors. Okay, so this results in the malnutrition, right? And within malnutrition, there is a concept called hidden hunger, right? So hidden hunger means the hunger which is hidden, means you it will not be overtly expressed. What is the feeling this? Okay, so the hidden hunger actually refers to malnutrition caused by deficiencies of vitamins and minerals, means the micronutrients, right? Which are required in very small quantity, but they are important. Okay, so here why the term hidden hunger has come means the affected people, they do not show the physical symptoms usually associated with hunger and malnutrition. Okay, so the protein energy malnutrition, you know what are all the different symptoms, mainly the stunting, then what is a lower what is a height, weight, etc. But people who suffer from malnutrition of micronutrients, they will not be overtly expressing these symptoms, but still they will be lacking this what is it, minerals or vitamins, and it will be expressed in many ways. So that is why it is called hidden hunger. So hidden hunger is actually the malnutrition arising due to lack of micronutrients, right? So according to the National Institute of Nutrition, Hyderabad, they have given the food pyramid. Okay, so how a healthy individual has to consume, what are all the different ingredients, which are the components to be there, and how he should consume. Okay, so it is in the shape of a pyramid. So at the base level, what is given is the grains, right? The cereals and pulses. Okay, so it says consume adequately. So you need to, according to the energy requirement of different people, which starts from 2000 kilocalories to 2200 for the sedentary person, then for the what is a physical person who is doing engaged in physical work, then for pregnant and lactating woman. So there are different categories actually. Okay, so according to the energy requirement, you need to consume these grains in adequate amount. Okay, then comes the fruits and vegetables. Okay, so there it says you eat liberally. Okay, so the recommendation by the NIN is minimum 300 grams of fruits and vegetables should be consumed per day. And we all know that most of us, we do not consume 300 grams. Maybe it may be ranging from 50 to 100 grams or 150 grams, but no one is consuming 300 grams. Okay, because the fruits and vegetables, their main source of the vitamins which are required. Okay, then comes the next, that is fat. Either your cooking oil or the butter or even the non-vegetarian food items. Okay, so eat moderately. Okay, there is no bar in eating. You can eat, but please eat at a moderation, at a limit. Okay, then comes the top, the tip of the pyramid. That is all the fast food, the processed foods like your pizza or burger or the ice creams or all high energy food products. Okay, so you eat sparingly. Okay, you can eat, but in very limited quantity, right? So this is the food pyramid. And apart from this, you also should follow regular exercise and be physically active. Okay, in order to digest and assimilate all this whatever you are consuming into the body. Okay, but unfortunately, what has happened is our food pyramid has just become reverse. Okay, now with the what is the increasing economic power, more and more people, they are going for the processed foods, right? So we eat more of the processed food, and because of the lifestyle also, because many people, they don't have what is it, time to prepare food products and all using the grains. So they go for the ready-made food products. Then they consume more of non-vegetarian, more of fatty items, and very less of grains. So that is because these things, they will supply the required fat, required protein, but they won't be supplying the required minerals. Okay, so minerals has to come from the grains, right? And exercise, of course, we don't have much time nowadays for the exercise, so that takes a back door, right? So this is the food pyramid for a healthy living, right? Now, coming back to micronutrient malnutrition, so this affects more than half of the developed world's population, or more than 2 to 2.5 billion people. Of course, now it is nearly 3 billion people. It is slightly old statistics, and around 820 million people are undernourished worldwide. So now it is nearly 1,000 million. And children below preschool children below 5 years, almost 150 million are stunted. So stunting is, of course, a symptom of micronutrient malnutrition. Then 45.4 million are wasted. Wasted means lower height to weight ratio. I think no, this is the other way. The stunting means lower height to weight ratio, or the reverse. Just I'm not getting it right. So around 45 million are wasted, and around 40 million are overweight. Okay. So the malnutrition contributes to loss of around 11% of GDP in Asia and Africa. So these are the two continents which are affected most by the malnutrition, micronutrient malnutrition especially. Then so the micronutrient malnutrition is globally a serious food-related health problem. Okay. So now, please, I'm underlining this because it is actually not the lack of food. So people will be consuming the adequate food, required food, but they are not sufficiently providing you the required micronutrients. Okay. So micronutrient malnutrition is actually classified as a food-related health problem, right? And the most important worldwide are the deficiencies of vitamin A, the iron, and zinc. So these three are the major micronutrients which are affecting the human health directly, right? And nearly 2/3 of all the deaths of children are associated with the nutritional deficiencies, and majority are from micronutrients. So this is as per the Global Nutrition Report of 2020. So so here is a comparison of just it is the data from UNICEF and World Health Organization, as well as World Bank Group. So the joint child malnutrition estimates of 2021. So it says that in about 53% of the children in Asia, they are stunted, and in Africa it is about 41%, slightly better. So in 2020, more than half of all the children under 5 were affected by stunting. They lived in Asia, and 2 out of 5 lived in Africa. And if you come to wasting, in Asia it is about 70%, in Africa it is 27%, and again it says more than 2/3 of all the children, means nearly 66% of the children under 5 were affected by wasting, lived in Asia, and more than 1/4 lived in Africa. And coming to overweight, that is childhood obesity. Okay, so about 48%, both. Of course, it is not specifically to children, even to adults also. So almost half of all children under 5 are affected by overweight, lived in Asia, and more than 1/4 lived in Africa. Okay, so this is the situation of malnutrition really, and especially the micronutrient malnutrition. So it says every child out of 2, they are micronutrient deficient, so lacking in iron, zinc, and vitamin A, the most important micronutrients, putting them at risk of a weak immune system, slow growth, learning difficulties, and lack of concentration. And every 2 in 3 girl child, okay, so or the adult woman, they are micronutrient deficient, lacking iron, zinc, and folic acid, putting them at risk of a weak immune system, slow growth, and low productivity. So this is the seriousness of this micronutrient malnutrition. Okay, and it is estimated that the loss of GDP due to malnutrition. Okay, so it is roughly estimated as India is the biggest loser, about $12 billion US is the loss due to micronutrient malnutrition, and many other developing countries like Bangladesh and Pakistan, then many of the African countries, they also have significant loss in GDP growth. Right? Okay, and the Sustainable Development Goals of UN, so 12 out of 17 SDGs of UN, so they have some of the other indicators related to nutrition. The most important one is the SDG 2, that is the goal 2, that is hunger and nutrition. Okay, so it has a direct bearing on the micronutrient malnutrition, and it is estimated that every $1 invested in proven nutrition programs, they offer a benefit of around $16, means 16 times or 1,600 times benefit is there. So that is why more and more governments, more and more countries are going to invest in micronutrient malnutrition to ease the micronutrient malnutrition, so that there will be larger benefits to humankind. So as I already told, the most important macronutrient malnutrition are arising due to three micronutrients, that is deficiency of three micronutrients, that is vitamin A, iron and zinc. And vitamin A, most of you must be knowing what is the role of vitamin A. So it is required for vision, then the immune response, then epithelial cell growth, bone growth, reproduction, and embryonic development, etc. Okay, now the vitamin A deficiency, that is in short form, it is called BAD. So that causes night blindness and as well as irreversible blindness. And vitamin A deficiency is the leading cause of preventable blindness in children, leading to blindness in about 2.5 lakh children each year. And the WHO has estimated that nearly 30% of the preschool children, means below 5 years age, they are affected by vitamin A deficiency, and about 5.2 million preschool children, they suffer from night blindness. Okay, and in India alone, about 36% of the population suffer from the vitamin A deficiency. Now, coming to the second element, that is iron. So the most important symptom of iron deficiency, as you all know, it is anemia. Okay, and anemia affects, and you know why iron is required, because this is a part of a hemoglobin and the heme part. And the anemia affects nearly 800 million women and children in India, and half of the cases are due to iron deficiency alone. Anemia can be due to other factors also, but more than 50% of the anemic cases are mainly due to iron deficiency. Okay, and the lack of iron also causes cognitive affects the cognitive development. That means the intellectual mind development, then resistant to infections, then work capacity and productivity and pregnancy. And nearly 8 lakh deaths occur due to iron deficiency anemia. About 3.7 billion people with iron deficiency are estimated in the world by the World Health Organization. And in India, about nearly 80% of the preschool children and about 56% of the women are found to be anemic by the family health survey of NIR, right? Now coming to the third element, zinc. So zinc is actually a cofactor for the DNA and RNA synthesis. So it is involved in the DNA and RNA synthesis through many enzymes. As you know that for DNA and RNA synthesis, you need a host of enzymes, and zinc acts as a cofactor for these enzymes. So, and these enzymes, they help in cell growth and differentiation, gene expression, etc. And the zinc deficiency leads to the impaired growth, then immune dysfunction, just like vitamin A. Then the severe deficiency can lead to mortality, then adverse pregnancy outcomes, abnormal neurobehavioral developments, etc. And nearly 50% of the human population is affected by inadequate zinc in their diet. Okay, and about 1/3 of the world population is at high risk. They live in low-income countries, and about 8 lakh children death worldwide happens due to zinc deficiency alone. So this is the WHO estimate. So this is a global prevalence of the macronutrient deficiency. So you can see that many of the so-called third world countries or the developing countries in the Mediterranean region, most of the countries in Africa, then India, the Pakistan, the Bangladesh, then the Afghanistan, then some countries in the Southeast Asian countries, and also the Mexico as well as the South American countries, right? So they all at the medium to high deficiency range, right? So the poor people who are living in this arid, okay, this is mostly whatever is marked is actually the arid and semi-arid regions of the world. Okay, so the poor people living in the arid and semi-arid zone, they suffer most from these macronutrient deficiencies, as they cannot afford a variety of food items in their diet. Okay, so please keep in mind that the concept of biofortification is not for people like you and me who have the access of a variety of food items like milk, fruits, vegetables, or even non-vegetarian items, but this is mainly targeting the poor people who spend most of their income on purchasing only the staple food. Okay, so their most of the income goes in staple food, and they cannot afford other food items, the variety of food items. So whatever elements are required, it has to come from the staple grain, whatever they eat, either rice or wheat or millets or whatever it is. Okay, so that is why the concept of biofortification has come, biofortifying the cereal grains, so that all the macronutrient deficiencies can be addressed through the food-based approach. So what is the biofortification? So as I already told in brief, in between that the whatever nutrients are required, it should come from the grains which we consume. Okay, so the development of micronutrient dense staple crop varieties using the best traditional breeding practices as well as the modern biotechnology. So wherever your traditional breeding practices cannot achieve this higher micronutrients, then you can go for the modern biotechnology. Okay, so this is the definition of the biofortification. So you are just developing or you are improving the grains of staple crop varieties with more nutrients. Okay, you are packing more nutrients in the grains so that whatever the poor people consume, it can supply all the required nutrients. So now it is different from two other items. The two commonly heard items, you must have heard about fortified products. Okay, well, nowadays if you go to supermarket, you can find a lot of fortified products, fortified what is it, biscuits, fortified atta, so many things are there. Okay, so the fortification means addition of an ingredient to the food to increase the concentration of a particular element. Okay, and the most common example every one of us knows, it is iodized salt. Okay, and also vitamin A, D in margarine, etc. But nowadays so many products are there, everything is fortified. If you go to a good supermarket, you can find everything is fortified, right? So fortification is actually after production of the food. Okay, so it is addition of nutrients to the food. So it is actually through processing, right? And similarly, there is another terminology called supplementation. So the supplementation is actually the addition of an element to the diet to make up for the insufficiency. Okay, so if your diet, whatever food you are consuming, is lacking the nutrient, so to immediately address that, you are going for supplementation. So the most common examples are the vitamin capsules or mineral capsules. Most of you must have consumed one or the at one or the other stage, especially the women participants, that iron and zinc vitamins are capsules. So it is commonly available. And the fortified food products, they will have the symbol F plus. Okay, so this is as per the government regulation, FSSAI regulation. So these are the two things which are commonly known: fortification and supplementation. Okay, so the most common supplementation program followed by the government of India was weekly iron folic acid supplementation. It is called BAFS. It was in practice since 2012 for the school adolescent boys and girls. And since 2006 itself, vitamin A supplementation program is underway for children below 5 years, especially the children who are going to Anganwadi. So they will be given the vitamin A supplemented the items. Okay, now both fortification and supplementation, they are short-term public health interventions. Okay, so most appropriate for acute cases of micronutrient deficiency. If the deficiency is too acute, then you have to go for supplementation, or you have to consume fortified food products. But they require infrastructure, but they require infrastructure, sophisticated processing technology, because I told in case of fortification, the nutrients are added after the food has been produced. Okay, so they need proper quality control, product control, and apart from that, there has to be purchasing power on part of the consumer. Okay, so we are talking about people in the semi-arid region, in the arid region, who are very poor, who have less economic power. So the purchasing power also will be less. Okay, so they can't go for a supermarket and they can buy a fortified food product, or they can't consume the vitamin capsules or zinc capsules. Okay, so the easiest way is actually through biofortification. Okay, and there is another type of increasing another approach for increasing the nutrients also, that is called agronomic fortification, agronomic biofortification, either through soil or foliar fertilization. But the success is limited and it is not feasible because it adds to the cost of cultivation. So your grains will be much more costlier, which the farmers are not going to get. So no farmer will be going to practice this soil or foliar fertilization with micronutrients. Okay, so to avoid these fortified foods or to avoid supplement vitamin or mineral supplements, what we need is biofortification. So initially I told the health comes from pharmacy, right? But our concept should change now. Health should come from farm, not from the pharmacy. So whatever you eat, that should provide you health, not the pharmacy. Okay, pharmacy visit should be very, very less. Only in unavoidable situations you should be going to pharmacy. So that is the concept. Okay, so this is just a summary of whatever I have already explained. So the dietary diversification, that is the easiest way. If we can afford a variety of food items, as shown here. So that is the easiest way to mitigate the micronutrient malnutrition. If that is not possible, the second approach is the fortification. So fortification needs the factory, means through processing, food processing, and you are artificially adding it, and it requires the quality control, product control, so many things. And apart from that, the consumers, they should have access to it. Economic purchasing power should be there. And the third approach is supplementation, that is through pharmacy, dietary supplements. But if you go for biofortification, so none of these are sustainable because you need to pump in a lot of money here. So fortification is a commercial one. Then the dietary diversification, the question of affordability, as I already told, and supplementation is a medical approach. So the only sustainable approach is biofortification, because here you are supplying the required micronutrients to the food itself. Okay, so it has to be part of food matrix, and there has to be high bioavailability, and it can reach the target people in pure form. Okay, so the target people is the poor people who are living in the most remote or less advantageous areas. So you should reach them. Whereas in the supplement, what is a fortified food products or the supplements, it may not reach them so easily. Okay, so the advantage of biofortification is that it implicitly targets the low-income households. It capitalizes on the regular daily intake of the staple crop, so that the staple grains itself can provide high micronutrients. Okay, and reach the poor in the rural areas with poor access to markets or healthcare system, as I already told, who cannot afford the supplements or the fortified products. Biofortification is the only strategy. And here actually it is one-time investment, means once you develop a variety which can accumulate more micronutrients in its grains through breeding approach, then that variety can be repeatedly used for sowing and for eating the grains, right? So the seeds that fortify themselves, so such variety seeds can be shared with the farmers so that everyone can grow this. Okay, and hence there is low recurrent cost. Okay, because the cost of only seed production and deployment is there. So you need not invest every time on development of biofortified varieties. Once you develop a biofortified variety, then the seeds can be handled like any other seed, any other hybrid seed or open pollinator variety seed. And in that way, it is cost effective, and it is sustainable in the longer term, because the varieties will continue to be grown and consumed year after year. Once a variety is released, then the farmers can go on growing this variety for years to come, and hence it is sustainable. So there are certain criteria has to be fulfilled. So this is mainly not for you, but for the researchers who are really engaged in developing the biofortified variety. So for the first and foremost is the crop productivity must be maintained. Okay, so even if you are developing a biofortified variety which is having high grain iron and zinc, but if it is low in yield, then you can't push it to the farmer, because ultimately the farmer's aim is more profitability out of the agriculture, and that has to be the aim of everyone, including the researchers also. Okay, so the crop productivity must not be compromised. It must be high yielding plus high micronutrients in the grains. Okay, so the micronutrient, and second criteria is that the micronutrient enrichment levels must be significant, should have a significant impact on the human health. Okay, so a marginal increase, a slight increase may not be enough. So there has to be substantial increase so that it really improves the health of the consumer who is consuming that biofortified grains. Okay, and the enriched levels must be relatively stable. This is a third criteria, because from season to season or from location to location, if you grow the variety, there should not be change in the nutrient content. It should be high in all the locations, in all the seasons. Okay, it should be stable. And fourth important point is bioavailability in the enriched lines must be tested. This is important. Okay, so you know that the bioavailability is a major factor. I think I have 1 or 2 slides on that. So whatever is available in the grains, not necessary that it is available for the body when you eat. Okay, so there comes a concept of bioavailability. Okay, so the bioavailability of these mineral nutrients in the biofortified varieties must be tested, and it must be high compared to the normal grains, right? And last and most important one is the consumer acceptance. It has to be tested. Okay, if there is any difference in the taste, okay, or smell or flavor, whatever it is, okay, then it is very difficult. The consumers may not be accepting, right? Because the micronutrients, though you know that it is required for the human body, but as a consumer, I always go with taste. I always go with whatever is white. Okay, that is why nowadays more and more people go for rice, not for the millet, because rice is white, right? So the taste and cooking quality is important. It has to be tested, and there should not be any difference compared to a normal variety. So the biofortified grain as well as the normal grain should be tasting same, should be having the same cooking quality, right? So these are the two major approaches through which you can improve the macronutrients in the grains. The first one is the agronomic biofortification, as I already told. It is through either soil fertilization, either iron sulfate or the zinc sulfate you are applying to the soil, or through foliar fertilization. You are spraying these solutions directly to the leaves, so that the leaves absorb these macronutrients and accumulate in the grains. Okay, but only if there is deficiency in the soil, this approach improves the macronutrient status in the grains. Otherwise, there is no advantage. Okay. Through different experiments in different crops, people have proved that it has only limited practical utility, because if the soil is not deficient in iron or zinc, then it is not going to improve the macronutrient of the grains. It only adds to the cost of cultivation. Okay, and hence it is not useful. So the other approach is the genetic biofortification, that is through the process of breeding. Okay, so it starts with the germplasm evaluation. Okay, so you need to identify a good donor which is having high iron and zinc. Then once you identify a high nutrient lines, you involve it in conventional breeding, then limited backcrossing, and through that you can develop a biofortified crop by combining high yield as well as high macronutrient content. Okay? And if it is not available naturally, because in many crops the variability for grain iron and zinc is very limited. Okay, there is not much variability. So in such cases, you need to go for other techniques like either mutagenesis or through other genomics or transgenic approaches, which so far there is limitations for this approach and not practiced in India anymore, right? And there is a term called harvest plus. Many of you must have heard, those who are especially in the field, they must have heard about harvest plus. Okay, so it is a global alliance of institutions and scientists seeking to improve the human nutrition, mainly by breeding new varieties of staple food crops consumed by the poor people who are living mostly in Asia as well as in the African countries. Okay, so these new varieties of crops should have more macronutrients through a process called biofortification. So the harvest plus is nothing plus you harvest the crop plus more nutrients. Okay, so that is why this term has come, harvest plus. So the process of biofortification is actually followed or practiced in the case of harvest plus. So it is an initiative by the CGIAR. You must be knowing about the CGIAR, just like ICAR in India. There is a CGIAR which has many institutes, and ICAR in India is one constant institute of CGIAR. So Harvest Plus is actually an initiative of the CGIAR involving many institutes, and it is coordinated by the CAIT Colombia, that is Center for Tropical Agriculture, Cali, Colombia, and the International Food Policy Research Institute, IFRI, located in Washington. Okay, so they are actually coordinating it, and there were many phases of this Harvest Plus program. It started way back in 2004 or so. The first phase was targeted 6 crops like rice, wheat, maize, beans, cassava, and sweet potato. And the last 4 crops mainly for the African continent, and rice and wheat across all the countries. And in the second phase, they targeted a few more crops like peanut, then peanut is the groundnut, then lentil, cowpea, pigeon pea, then sorghum, pearl millet, then barley, banana, then potato and yams. Okay, so these are some of the successful products out of a biofortification program through Harvest Plus. So the iron bean, especially for the African countries, then iron pearl millet, both for Africa as well as for India. Then vitamin A, orange sweet potato, it is called OFS, means orange fleshed sweet potato, which was first released way back in 2007 in Mozambique. After the impact study, it has been found that it significantly improved the vitamin A status of the children as well as the women through the consumption of vitamin A enriched sweet potato. And for this discovery, the scientists who are involved, that is mainly the Howard boys and other 3 scientists, they were given World Food Prize in 2016 for this development. Then enrichment of vitamin A in cassava, again for the African countries, then vitamin A enriched maize, then zinc wheat. Of course, in India also zinc wheat is available nowadays, then zinc rice, then zinc maize. Okay. Yeah, so as I told, in India, mainly two crops are targeted. One is the pearl millet, that is iron-rich pearl millet. So the first variety through ICAR-IIMR and Harvest Plus released in the state of Maharashtra was Dhanashakti. It was released in 2014. And then another hybrid, ICMH 1201, that is called Shakti 1201, was released later on. So this provides up to 80% of the daily iron needs. Okay. And in case of wheat, high zinc wheat is being developed. So the zinc wheat, there are two varieties developed by the BHU3 and BHU6, which provides up to 50% of the daily zinc needs of the target population. Right. So you can see that mainly Rajasthan and Maharashtra, these are the two states which are mainly growing the biofortified pearl millet, and the UP, Bihar, and Jharkhand. These are the three states mainly growing zinc enriched wheat. Okay, and apart from that, there is a zinc rice also. Nowadays, many rice varieties have been released by ICAR, which are rich in zinc, and lentils. They are also having high iron content. These have been developed. Okay, so coming to Indian scenario, so I am not going to bother about you with the statistics. This will be available on internet. You can search and find out. There are many reports which states that there is the status of micronutrient deficiency in India, especially in the preschool children, the school-going children, as well as the adolescent girls, as well as the pregnant or lactating woman. It is in a very severe condition. It's in a very alarming condition. Right? Okay. So looking at the deficiencies of micronutrients, the government of India, the Department of Biotechnology, way back in 2004 itself, that is almost 20 years back itself, it initiated a India Biofortification program, mainly targeting rice, wheat, and maize to biofortify the rice, wheat, and maize with iron, zinc, and provitamin A. Okay. And during 11th plan period, the DBT funded also some biofortification program in groundnut as well as in pigeon pea for elevating the vitamin A deficiency, and sorghum biofortification for iron, grain iron and zinc content through ICAR, IIMR, and the Parbhani University. And ICAR started a consortium research platform on biofortification in 2014, almost 10 years back. Biofortification selected crops for nutritional security. So the first phase was 17, then 17 to 20. Second phase was in, and now third phase is going on. So under this, there are many crops like rice, wheat, maize, sorghum, pearl millet, and finger millet, and foxtail millet are being targeted for improving the grain micronutrient content. Yeah, so that that is about biofortification, the extent of micronutrient malnutrition, and how biofortification helps, and what is the science of biofortification. Right now, a few slides I will go to about the millets and how it has been a successful event in case of millets. So millets, as you all know, we call them as a harbinger of everything revolution, because in the changing climatic scenario, millets are the most potent crops that will sustain the livelihoods, health, and rural economy. Okay, so as a winning source and a resource for food, feed, fodder, biofuel, and alcohol. Okay, and you all know that all the millets, they are drought tolerant. Most of the millets are drought tolerant. They require less inputs. They are affected by less disease and insects, and above that, they are highly nutritious because they have high protein content, high fiber, and also high mineral composition, both macronutrients as well as micronutrients. And above that, they are gluten free. So they are called as nutri cereals. And by Gazette order, Government of India has officially recognized them as nutri cereals. Okay, in 2018. So this is the nutritional composition of the different millets compared with wheat, rice, as well as maize. So you can see that in case of carbohydrates, that is the energy value which provides the energy. The carbohydrate content is almost the same, except in case of rice, where the carbohydrate content is high. Then protein content, you can see that some of the millets, they have high protein content, like pearl millet, almost 11%. Then little millet about 10%, then foxtail millet 12.3%, proso millet 12.5%. So among the millets, proso millet has very high protein content, and among other cereals. Wheat, of course, wheat has a high protein of almost 10.6 to 11%, but rice and maize, they are slightly lower. Okay, and in the energy level, as I already told, the carbohydrate levels are almost equal, except what is a milled rice. So you can see that the energy levels are almost same, except in case of barnyard millet or in case of finger millet, the energy levels are slightly lower. And most of them, they have high dietary fiber content, like sorghum has 10%, then 11% in case of pearl millet, finger millet 11%. Okay, so compared to rice, you have only 2.8%. That too, if you polish more, more of fiber is lost. Okay, and minerals, you can find that some are having a better mineral content compared to rice and on par with the wheat. Okay. Yeah. So this is the nutritional component with respect to both macronutrients and micronutrients. So please keep in mind that not all millets are good in all the minerals. Okay, or not all minerals are having high protein. Okay, so please keep in mind that each millet or each grain has its own advantages, right? So each will have one or the other component which is in more quantity, right? So coming to minerals, you can find that if you take calcium, so finger millet is the richest source. Okay, it has almost 350 to 360 milligram of calcium per 100 gram of the grain, whereas your uh, rice has about 10 milligrams only. So it is almost 30 times what you are finding in rice. Okay, in case of milk also, because we all know that milk is a good source of calcium, but in milk also it is about 100 to 120 milligrams per 100 ml. Okay, so finger millet is nearly 3 times of the milk also. So finger millet is a very rich source of calcium. So whenever calcium deficiency is there, people can switch over their food to finger millet based food products. Then phosphorus also in some, most of the what to say, millets, it is high. Then similarly magnesium. Then in case of micronutrients like iron and zinc, so you can see that some millets like pearl millet on an average, it is having about 6 milligrams per 100 gram, and finger millet has 4.6 milligram per 100 gram, and barnyard millet also has high iron. So compared to wheat and rice, these are rich, and compared to rice, of course, it is much richer. And same is the case with zinc. Pearl millet has a better zinc content than again finger millet, foxtail millet. Also, barnyard millet has higher zinc content compared to rice. Okay, and they're almost on par with the wheat, and some other minerals, some other vitamins also. The thiamine, niacin, riboflavin, B1, that is B6, then beta carotene also higher in some of the millets compared to rice. Yeah. So a few minutes back, I talked about bioavailability. Okay. So whatever is available in the grains, it must be available to the human body. Then only it is useful. Otherwise, just if it is present in the grain, but even after consumption, if it is not available to the body, it is not going to improve your health. Okay. So bioavailability is one important concept. Okay. And it has been observed that even in case of rice, wheat, the bioavailability is less. In case of iron content, the bioavailability is about what to say, about 8% in case of rice. In case of wheat, it is only 5%. And in case of millets also, like finger millet, it is 6%, sorghum 4%, and pearl millet 7.4%, right? And similarly, the zinc bioaccessibility, though now better estimates have come both for millets as well as for cereals. So in case of rice, the zinc bioaccessibility is slightly better, about 21%. Then wheat, it is 9%. And in rest of the millets, it is about 5 to 8% only. Though with the latest technology of assessment, almost zinc bioavailability is assessed to be estimated to be about 20%. Okay, so whatever is available in the grain, about 20% of that will be available to the body, and rest is excreted. Whereas in case of iron, it is less than 10%. Okay, so even if the grains have better iron content, only a portion of that, means only about 10% of that will be available to the body once you consume. Okay, and there are many factors which decide the bioavailability, like you know that the millets are good in many phytochemicals like phytic acid, polyphenols, tannins, etc. So they greatly reduce the bioavailability of minerals. This is one thing. Though the phytic acid, polyphenol, etc., even the tannin, they have some good effect also, because though once upon a time they were considered as anti-nutritional, but nowadays they are no more considered as anti-nutritional because they provide the antioxidant activity in the body, and thereby they reduces the oxidative stress, that is the free oxygen radical O2 stress. So thereby they're useful in reducing the aging of the human cells. But on the other hand, they slightly reduce the bioavailability of mainly the cations, means the ions which goes towards the cathode, means positively charged ions like iron or zinc or manganese. Okay, so whenever there is very high phytic acid or polyphenol, the bioavailability gets reduced. Okay, and the anti-nutrients, of course, the term is slightly misnomer because the polyphenol, phytic acid, etc. They cannot be considered as anti-nutrients because they are helpful also, as I already told. But most of these anti-nutrients can be removed by decortication or malting, fermentation, or roasting, flaking, etc. Means different processing techniques have been developed whereby you can reduce this nutrition factors like phytic acid or polyphenol. Even simple soaking will improve the iron and the availability of iron and the zinc content in the grains. And the reduction of anti-nutrients during plant growth and development is therefore a promising strategy. Okay, so if you can have some breeding strategy to reduce the polyphenols or to reduce the phytic acid, that will also be a good strategy. But the phytic acid, as you all know, it is a storage form of phosphorus in the seeds. Okay, so the phosphorus is actually required for the seedling development, the establishment of seedling, especially for the root growth. The phosphorus is required, essential, right? So if you reduce the phytic acid, so what happens is that the seedling establishment will be poor, and once the seedling establishment is poor, there will be poor plant stand and the yield levels will be lower. Okay, so you need to strike a balance between what is reducing the phytic acid and also to maintain the plant vigor. Okay, so you can't go on reducing the phytic acid just to enhance the bioavailability. So these are interlinked things, right? So I was mentioning the study of bioavailability is a very complex topic. So you on this just one figure, I can go on lecturing for half an hour because it is very complex. You can't easily determine the bioavailability of any mineral by any grain from any grain. Okay, so first thing is the genetic selection and production practices. So it determines the content in the grain. Okay, and that grain you will be consuming. So once you consume, the total plant content will go into the human body. Okay, now this undergoes a different process of so this undergoes a different process of ingestion, absorption, and utilization, and finally it leads to the bioavailable content. Okay, so once the digestion is taking place in the human body, so it undergoes different processes, and it is also affected by different components. Okay, other meal components. Okay, you know that we use different ingredients in our food, the spices especially. They improve the bioavailability, right? Apart from improving the taste, they also improve the bioavailability, right? Then the certain organic acids like the oxalic acid or citric acid, whatever you know that many people they squeeze the lemon on the what is the preparations. Okay, apart from improving the taste, it will also help in improving the bioavailability, right? And similarly, there are many retardants also which reduces the bioavailability of micronutrients. Let us not go into the details of that. And individual's characteristics. This also has a major role on the bioavailability of minerals. Okay, so you know that a healthy individual will be able to absorb better. Okay, so the bioavailability of minerals will be better in a healthy individual compared to an unhealthy individual. Okay, and there are racial differences. The people from the tropical region, people from the temperate region. So temperate region, they will have different body physiology, and hence their absorption capacity or the bioavailability will be differing from people to people, from region to region, and from meal to meal. Okay, and the processing and preparation. Okay, and you know that many processing techniques, they help in enhancing some of the micronutrients. At the same time, they help in reducing or they lead to loss. You know that in case of rice, the polishing is a major culprit for lower nutrient content of rice, because the more you polish, the more white it becomes. So it looks good. So everyone prefers a white colored rice than a brown rice. Okay, not brown rice, brown colored rice, right? Nowadays, even the just dehulled rice are also available in the market, but less polished compared to the highly polished. So highly polished is always attractive, to be more white, but it contains only carbohydrates, because the major nutrients, especially because in the process of milling, you will be losing the germ also. So the germ contains a lot of proteins as well as the fat content. So you'll be losing all those things. So finally, what you consume will be only carbohydrate. Okay. So the processing and preparation, the cooking technique also determines the bioavailability of minerals. Okay. So these are the complexities of bioavailability in human nutrition. Yeah, so coming to the millets, biofortification in pearl millet. So just one slide about the status of the crop. Most of you must be knowing, because you are all people who are in the field. So you know what is the extent of pearl millet grown in India. So it is a highly drought tolerant warm season crop. Apart from India, it is grown in about 25 in many other countries, in about 26 million hectares in the harshest environments in the arid and semi-arid tropical regions of South Asia as well as sub-Saharan Africa. And India is the leading producer. Almost 50% of the pearl millet is produced by India, with an area of about 7 to 8 million hectares, and the production of about of course, the production is slightly increased now, about 9 to 10 million tons, with a yield level of 1,300 to 1,500 kg per hectare. Okay, so it makes best use of the scarce water resources, because you know that mostly these are all grown in a very drought-prone areas, and basically a rain-fed crop grown in Kharif season, but it is also emerging as a irrigated rabi as well as a summer season crop, because the yields of summer season crop is very high. It is grown under well-managed conditions, and the rain-fed grain yield is up to 1 ton per hectare, whereas the summer season yield can be up to 4 ton per hectare, and it is highly nutritious. It has a high protein content of 10 to 12%, then high iron and zinc, double that of wheat. Okay, and it is also acts as an excellent forage crop with low hydrogen cyanide content, SN content, and rich in protein. That is fruit protein, then calcium, phosphorus, and other minerals. Okay, so you know that most of the pearl millet is grown in Rajasthan, then followed by Gujarat, then Haryana, UP, Madhya Pradesh, and Maharashtra. Okay, and little bit in Karnataka. Yeah, so coming to the biofortification, so the biofortification research in case of pearl millet started almost 15 plus years, or nearly 18 years back, in ICAR-IIMR under the Hariprasanna pages. So they tested the available varieties as well as hybrids for grain, iron, and zinc. So they found out that iron ranged from 42 to 67 milligram per kg, and zinc 31 to 61 milligram per kg in the case of iron itself. Iron ranged from 31 to 61 milligram per kg in case of hybrids. And zinc also had a similar wide range, that is 37 to 52 milligrams in the varieties, and 32 to 52 milligrams in case of hybrids. Okay, so there was significant variability was observed for iron in the germplasm, that is 51 to 121 milligrams per kg, and zinc from 46 to 87, means almost double range. Okay, milligram per kg, with positive correlation. So there is a positive correlation between grain, iron, and zinc. So if a grain iron is high, the zinc will also be high. Okay, so the EAD race germplasm from the Africa, it was a promising resource for high grain iron and zinc density. So identified the this germplasm from the Africa, and they through different breeding techniques, they improved this. So this was the first biofortified variety, that is called ICTP 8203. ICTP 8203 was the original germplasm line collected from Africa, which was available in ICAR-IIMR, and they improved it through selection, and finally they developed ICTP 8203 FP 10-2. Okay, so it was developed with the progeny testing, was commercially released in India in 2012 officially, or 2014 maybe, I think. Yeah, 2012 it was released in Maharashtra, and later it was notified in 2014 with the iron content of 71 milligram per kg. So this was the first biofortified variety released for commercial cultivation in India. That is ICTP 8203FP 10-2, which was named as Dhanashakti. Okay, so Dhan means Shakti. Yeah, so this is the high iron commercial cultivars of pearl millet, ICTP 8203FP 10-2. So it is an agricultural but open pollinated variety. It is not a hybrid. It's an open pollinated variety with 72 to 74 ppm iron. Then another from private company also 86M86, that is pioneer hybrid with 54 to 60 ppm iron. So these were the first two, one variety and hybrid. Then another variety hybrid was ICMH 1201. So it was released as Shakti 1201. So both of these, they can supply, can provide up to 80% of the daily iron needs of the consumers. Okay, so in that way they can improve the micronutrient status of the persons, the consumers who who consume this iron enriched or pearl millet, biofortified pearl millet, right? So these are some of the cultivars available for the farmers. So Dhanashakti, as I already told, it is the first cultivar with the very high iron of 71 to 81 ppm. Then zinc of about 40 to 45 ppm. Then it has a grain yield of 2,200 kg per hectare, and the duration is just 76 days. It was developed by MPKV Dule and notified for cultivation in 2014. Then it is an early maturing, bold seeded, globular, shining, slate gray colored seed, resistant to downy mildew disease. And it is adopted to Maharashtra. Initially, it was tested and released for Maharashtra, but later on, through all India testing, it was released for all India. So it is adaptable to Maharashtra, Karnataka, Andhra Pradesh, Tamil Nadu, Rajasthan, Haryana, MP, Gujarat. Means almost all the states where the pearl millet is grown. Okay, and this is another one, EHP 1200FE, that is MH2072. So it has a high iron content of 77 ppm, zinc content of 39 ppm. The grain yield is higher here. It is as it is a hybrid, so it is 3.17 ton per hectare, and the duration is 78 days, and it is developed by NARP Center, Aurangabad, from MPKV. Then it is a medium maturing hybrid, yellow anther color, compact cylindrical ear heads, and highly resistant to downy mildew disease. Okay, so it is adapted to many of the countries, like many of the states like Rajasthan, Gujarat, Haryana, Punjab, Delhi, Maharashtra, and Tamil Nadu. And this is another one, HHB 299. So it also has a high iron and zinc with higher grain yield, developed by CCS Haryana Agricultural University, Hisar, released in 2018. And it is medium maturing hybrid with 81 days of maturity. Then the identification mark is purple anther color, compact lanceolate ear heads, then resistant to downy mildew and smut. And it is also adapted to most of the pearl millet growing states. This is another one, HHP 311, that is having a very high iron content of 83 ppm, zinc of 39 ppm, and grain yield 3,173 kg per hectare with a duration of 80 days. And it is again developed by HAU Hisar, and is a medium maturing hybrid, compact panicle, having gray colored hexagonal grain. This is a highly resistant to downy mildew and other diseases, and it is adapted to almost all the states. Okay, and these are some other hybrids which are having high iron and zinc, which are adapted to the zone A1, A and B. Means all three zones. You must be knowing that there are three zones in case of pearl millet. The zone A1 is the most driest part of the western India. That is the Rajasthan, almost the desert region, Badmer, then Bikaner, etc. Then comes the A zone, part of Rajasthan with good irrigation facilities, good rainfall, and also part of Haryana as well as Gujarat. Then comes the B region, that is the Madhya Pradesh, Maharashtra, and all, where it is cultivated in the well-endowed conditions. So the yield levels are also much higher in B. So these hybrids are all adapted to all three zones, that is A1, A, and B, with the high iron and zinc content, right? And these are some other biofortified pearl millet varieties. I mean, they are not varieties actually; they are hybrids, but in general terminology we call it as varieties. But there are many hybrids are there, and some varieties are also there, like Phule Mahashakti, then Moti Shakti, etc. They are the varieties. Okay, and from 2018 onwards, ICAR has set up a criteria for release of any pearl millet hybrid or variety. So the criteria is that apart from high yield, because now under ACRP trials, we see only high yield. Okay? But apart from high yield, there has to be high micronutrient content also. So the green iron content must be more than 42 ppm and zinc content must be more than 32 ppm. So even if a hybrid which has very high grain yield or a variety which has very high grain yield, but if it is not possessing this much grain iron or zinc content, then it will not be recommended for notification, means it will not be released in India for general cultivation, right? So all the varieties or all the hybrids nowadays coming out of the ACRP system will have better iron and zinc, means at least more than 42 ppm iron and more than 32 ppm zinc. Okay. Now coming to sorghum. So you know that though now sorghum has taken a back seat, it was one of the important crops in the semi-arid region. So fifth most important cereal in the world, and grown in more than 100 countries with about 44 million hectares and a production of annual production of around 66 million tons. It is a crop of subtropical and semi-arid regions of Africa and Asia, and it is still a dietary staple of almost 300 to 400 million people in the African continent, though not fully stable in case of India. The share has come down, but still some of states like your Maharashtra, then northern Karnataka, they eat a lot of sorghum still, and it is a C4 plant like any other millet, and it is heat and drought tolerant. And you all know that there are two types of sorghum. One is Kharif season or the rainy season adapted sorghum. Another one is Rabi or post-rainy season sorghum. So the post-rainy season sorghum mostly used as food, mostly consumed in the regions in which it is cultivated. That means in the inner, the central Maharashtra, the northern Karnataka, and also some parts of Telangana, though now consumption has reduced much in the Telangana. Then the inland regions of central, eastern, and western Maharashtra, northern Karnataka, the per capita consumption in the rural areas is very high, almost 30 to 50 kg per year, whereas in the urban area it is about 10 to 30 kg per year. And it accounts for about 35 to 40% of the total intake of calories, protein, iron, and zinc in the dominant consumption region. So the region which I have just mentioned means the central, eastern, and western Maharashtra and the northern Karnataka. And it used to be a cheap source of energy, protein, iron, and zinc, next only to bajra among all cereals and pulses. But now it is not cheaper. As you all know, it is costly compared to rice and wheat. Then it contribute about more than 50% of the iron and zinc requirements in the low income group populations. Okay. And this is the crop status in case of sorghum. So already released the hybrids or varieties. So what is the range? So we have about iron content in the range of 25 to 28 ppm and zinc in the range of 15 to 18 ppm. So, and there are some specialty varieties like the varieties from MPKV Rahuri, which are good for different uses, like the papad variety or the hurda variety. It has slightly better grain iron and zinc content compared to the normal grain sorghum. Okay. So through breeding efforts, we are trying to improve. So these are some of the released varieties of sorghum which we are trying to improve. So they are having good yield, but average nutrients. So we are improving the nutrient content in these high yielding elite cultivars, popular cultivars, following the conventional breeding, the just hybridization followed by backcrossing techniques. And these are some of the donors which are used in the hybridization program, which are having slightly better iron and zinc, but agronomically they are poor. So it becomes a difficult task to combine high yield as well as high iron and zinc. So still we are trying to develop some varieties in case of sorghum for the last 7 to 8 years. And these are some of the varieties. They are not biofortified per se, but what you can say is that they are having higher grain iron and zinc content compared to the normal grain sorghum. Okay, so one is Parbani Shakti, which was released for the state of Maharashtra 2-3 years back, developed by Parbani University. Actually, the line is from ICAR-IIMR, and they have identified it, and through multi-location trials, they have identified it, Parbani Shakti. So it has slightly better grain, iron, and zinc depending upon the soil conditions. So if it is grown under good soil conditions, they will have better grain, iron, and zinc. So that is Qurbani Shakti. And we have two colored sorghum varieties. So that is yellow colored sorghum varieties. CSV 60 yellow. It is developed and released for all India. It is developed by the Dr. PDKV Akola, and it was released last year in beginning of the 2024. So CSV 60 yellow, and it has a yield level of 2.7 to 2.8 ton per hectare with slightly better grain iron content of 31.6 ppm iron and zinc of 24.4 ppm, and the protein content is slightly higher. It is about 11.9 to 12%. Okay, so that is a yellow sorghum variety. So apart from the advantage of yellow sorghum, it also has better grain iron and zinc. And another variety was identified for release, not at Gazette notified, but identified for release this year. That is SPV 2906 with a yield level of 25 to 26 quintal per hectare. And this also has slightly better grain, iron, and zinc content compared to the normal sorghum. Okay, so these are the two or three sorghum varieties with better grain, iron, and zinc content compared to the normal sorghum. Now coming to the third group, that is small millets. So just I will rush through 2 or 3 slides. So this is the distribution of small millets. You know that the small millets are not uniformly distributed. Some small millets are distributed in some states only. For example, Karnataka accounts for nearly 65% of the finger millet area as well as production, whereas the foxtail millet is mainly coming from Karnataka and Andhra Pradesh. Almost 95% of the cultivation is in Andhra Pradesh and Karnataka. And if you see the barnyard millet, almost 75% is grown only by Uttarakhand. Then a few northeastern states and the UP. So kodo millet, little millet and kodo millet, if you see, mainly grown in Madhya Pradesh. Madhya Pradesh is actually the little millet belt, and Chhattisgarh it is the kodo belt. So previously they used to call it as kodo kudki belt, the Chhattisgarh Madhya Pradesh region. And Maharashtra, of course, it grows a lot of pearl millet, then sorghum. Karnataka also grows sorghum in the northern part, and the southern part it is finger millet. Okay, so they are the crops of antiquity, means they're olden crops. The little millet, the kodo millet, and the barnyard millet, they originated in India, right? So they are Indian crops. Then they're suitable for dry lands. They can provide food and nutrition security of the disadvantaged people, especially in the tribal people who are living in the hilly region, etc. So they mainly depend on these small millets, and they require less water, mature early, and cultivated in scarcity conditions, and they are highly resilient in adapting to the different ecological conditions, climate change compliant. Okay, so in that way, they are already climate change compliant. They can adjust to the available environment. Okay, if there is a good rainfall, good input availability, they can grow well. But if there is less rainfall, there are drought condition, high temperature condition, then also they can grow and give some grains, okay, compared to the fine cereals. Okay, and this is roughly the area. Of course, the area has further come down in case of other crops than finger millet. Finger millet still it has about 10 to 11 lakh hectares, about 11.4 lakh hectares to be precise, with a production of 18 lakh tons in the yield level of 1,600 kg. And Karnataka, Uttarakhand, Maharashtra, Tamil Nadu, and Andhra Pradesh are the important. So the states which are growing finger millet, then foxtail millet, the area is about 15 to 20,000 hectares only, mainly confined to Karnataka and Andhra Pradesh. The kodo millet, about 1.5 lakh hectare is there, mainly confined to Chhattisgarh and Madhya Pradesh, the tribal regions. Then the little millet, it is about again about 1.5 to 1.8 lakh hectares, mainly concentrated in Madhya Pradesh, Chhattisgarh, and also in Tamil Nadu, and in some northeastern region. Then proso millet, about 20,000 hectares only, mainly in Tamil Nadu, Bihar, and some northeastern region. And barnyard millet, the area will be around 70 to 75,000 hectares. So these are slightly 10-year-old data. So nowadays we are not getting even individual crop data because the government of India is only clubbing all these small millets together other than finger millet. So they give the data of sorghum, they give the data of bajra, they give the data of finger millet, but the remaining 5 small millets, they club together and they call it as other millets. Okay, so we are not getting individual data, but still barnyard millet is grown in about 70 to 75,000 hectares, mainly in Uttarakhand and some regions of UP, then Tamil Nadu, and in some northeastern states. Okay. And this is the nutrient base level and the target. So the base level is fixed as 25 ppm for iron, and for zinc it is about 20 ppm. And our target is iron content should be more than 45 ppm and zinc should be more than 20. Okay, so this is the range in some of the released cultivars of finger millet. So iron is in the range of 14 to 48 milligrams, and with a mean of 29.7. Zinc is in the range of 14 to 30 ppm, that is milligram per kg, with a mean of 23.2. And calcium is in the range of 1939 to 3928. Then magnesium 120 to 239 ppm, phosphorus 1821 to 4971 ppm, and protein is in the range of 4.9 to 14.5. But in general, the finger millet has about 6 to 7% or 6 to 8% at the maximum protein only. And calcium phosphorus ratio, that is molar ratio, is 0.33 to 1.4. So this actually, the calcium phosphorus ratio actually determines the availability of calcium as well as other micronutrients. Okay, and some of the high calcium contents identified by the ACRP center at Bangalore is GPU 28, then VR762, KNE 1034, then M8362, like that MR1, MR6, etc. These are some of the old varieties which are having high calcium content, right? And 3 of the small millet latest varieties were released by the Prime Minister during 2022 World Food Day. So 2 are of finger millet, CFME1, which is termed Indravati. It is released from the Vijayanagaram Center of ACRP. Of the center is under Angro. So it has a high grain yield of 35 to 40 quintal per hectare, and resistant to finger and neck blast diseases, and high calcium content of 428 milligrams, that is 4280 ppm. Then iron content of 58 ppm and zinc content of 44 ppm. So this is released for cultivation for the states of Andhra Pradesh, Tamil Nadu, Karnataka, Pondicherry, and Odisha. Then CFME2, that is developed by our Hill Millet Research Station at Waghai, Gujarat, and it has high grain yield of 30 to 35 quintal per hectare and high dry store yield of 85 to 90 quintal per hectare. Then it is resistant to blast and stem borer, and the crude fiber is about 3.4% and high calcium content of 4740 ppm. It is again recommended for the states of Andhra Pradesh, Chhattisgarh, Gujarat, Maharashtra, and Odisha. And in case of little millet, one variety with a high micronutrients has been released in 2022, that is Jaika Sama 1. So it is high yielding with 18 to 20 quintal per hectare yield, and it has a high tillering capacity of 8 to 10 tillers, tolerant to insect pests and foliar diseases, and it has high protein content of 14.4% and also high iron content of 58 ppm. So this is again recommended for states of Maharashtra, Andhra Pradesh, Telangana, Tamil Nadu, Pondicherry. Okay. Right. So coming to the package of practices, cultivation practices, I am sure most of you are in the field, so you know well how to grow these millets. So just I will give a brief account of the package of practices followed in case of pearl millet. So we started with the process of biofortification, then we came to the cause of millets, and within millets, the biofortification of millets. Okay, so please keep in mind that the biofortified varieties of the pearl millet are as good as or is same as the other varieties or hybrids of pearl millet. So it doesn't require any special growing condition or package of practices. So it can be raised like any other pearl millet variety or hybrid. Okay. So the land preparation, you know, I don't have to tell. And the time of sowing in case of Kharif in zone A1 up to mid of July. And in case of zone A and B, it is the last week of June to first week of July is the appropriate time for sowing. And in summer, it is up to second fortnight of February. That is in case of Gujarat, Punjab, and UP. And in zone B, the first fortnight of March, that is Tamil Nadu and Karnataka. In southern region, they usually take it as a summer crop with a complete irrigation, right? So the best temperature for crop growth of bajra is about 20 to 28. That is the optimum temperature, okay? So, but we all know that pearl millet can sustain up to 40 degrees or 42 degrees for a few hours or a few days. But the ideal temperature for good growth and high yield is 20 to 28 degrees centigrade. Okay. And the seed rate is 4 kg per hectare. Line sowing, only line sowing is recommended. And the spacing, depending upon the zone, the spacing is different. In case of A1 zone, it is 60 centimeter row to row. And so that will result in about 1 to 1.25 lakhs per hectare. The plants means 60 centimeter between, row to row, and between the plants about 12 to 15 centimeters. Okay, so that will result in about 1 to 125,000 plants per hectare. Then in zone A and B, it is closer spacing is followed because it is grown under better management, so yield levels are higher. So it is grown, it is spacing of 45 centimeter row to row and 12 to 50 centimeter plant to plant within a row. So it will result in about 1.75 to 2 lakhs plants per hectare. And in case of summer irrigated condition, even a higher plant population is maintained, that is about 2.25 lakhs per hectare, because you are providing the irrigation, you are providing good management. So naturally, more number of plants means more yield. Okay, and the planting plant to plant distance is 10 to 15 centimeter within a row, and the planting depth is about 2 to 3 centimeter. Okay, and you need to follow the seed treatment as much as possible. So Trichoderma harzianum about 4 gram per kg of seed, or Thyron 75% dust, 3 gram per kg. It helps in controlling of soil-borne diseases in the initial period. Then the sulfur powder, the 300 mesh sulfur powder, at the rate of 4 gram per kg of the seed, it also helps in controlling the smut disease, because you know that smut is a seed-borne disease, right? So the sulfur treatment, it helps in control of this smut disease. And metalaxyl, that is Apron 35 SD, 6 gram per kg seed. This is also practiced. Then Bacillus prumilis, that is INR 7 strain, or Ketosan at the rate of 10 gram per kg seed. It controls the downy mildew. Okay, because downy mildew is an important disease in case of pearl millet, so as blast. So for the control of downy mildew, either metalaxyl or the biocontrol agent Bacillus prumilis or the Ketosan can be used at the rate of 10 gram per kg. And biofertilizer as much as possible available. You can put azospirillum, resilience, and aspergillus avamori at the rate of 25 gram per kg of seed. You can use for seed treatment. Okay, and the requirement of fertilizers and manures, it is about 5 ton per hectare farmyard manure. And the requirement of nitrogen and phosphorus. Potassium is not usually recommended because our soils are rich in potassium. So potassium is not recommended for pearl millet or any other millet. So in zone A1, the recommendation is 40-20 kg per hectare. And in zone A, Gujarat, where high management condition is followed, a higher dose of 80-40 can be practiced. In Haryana, again, it is 40-20. And in Jaipur, it is 60-30. And UP, again, with the good irrigation, they go for 80-40. Then Maharashtra, the followed fertilizer content is 60-40, Karnataka 50-20, and Andhra Pradesh 50-20. Tamil Nadu again 80-40 because they grow under irrigated conditions during summer with good management and irrigation. Okay, and in case of zone A1 60-30, then zone A Jaipur 80-40, Hisar 120-60. These are all under high management conditions. Then half of nitrogen should be at sowing, half of nitrogen 25 days after sowing, that is after the weeding, making the field completely weed free. You can go for the top dressing with another 50% of the nitrogen. Okay, and micronutrient, though no one is following, there is a recommendation 10 kg per hectare zinc sulfate or application, that is soil application, or foliar spray of 0.2% zinc sulfate tillering to pre-flowering stage. In zinc deficit soils, you can go for soil application or foliar spray, which will improve the grain yield. Okay, so but if the soil is not deficient, then there is no point in going for this because it is not going to give any advantage, right? Then intercultivation and weed control. So 2 hoeings and weedings at 15 and 30 days after sowing. So the crop should be weed free after 30 days, right? Then pre-emergent application of atrazine, that is 0.5 kg active ingredient per hectare with the 1 hand weeding is sufficient in case of pearl millet. Okay. Now irrigation or drainage. So basically it is a rain-fed crop, but nowadays the irrigated crop is also getting importance. So under rain-fed conditions, if there is a prolonged dry spell, irrigate at critical stages, that is at tillering, flowering, and grain development stage. So that the grains will not get shriveled. Okay. And in summer, minimum 4 to 5 irrigations, depending upon the soil type and climatic. And this is, I'm telling the minimum. Many times more may be required, depending on the soil type and climatic condition. Okay. So, and whenever during rainy season, if there is excess rain, drain out the excess rainwater to avoid waterlogging, because they cannot tolerate waterlogging continuously, right? And disease control, as I already told, downy mildew is an important disease. So mostly millets are grown without any pesticide or insecticide, but there is recommendation in case of downy mildew, you can go for a Ridomil spray at the rate of 100 ppm foliar spray. Then in case of blast, go for carbendazim at the rate of 0.1% active ingredient for spray. And in case of rust, dithane M45, 0.2%, thrice commencing from 1 month old crop at 10 days intervals. You can go for this spray. Then smut, it is mainly a seed-borne disease. So seed dressing with sulfur or thiram 75 at the rate of 3 gram per kg seed will be sufficient. Then ergot, the foliar spray for thiram at the rate of 0.2%, starting from 50% flowering stage, will help in controlling ergot disease. And in case of pests, white grub, especially in the sandy areas, as in Gujarat and Rajasthan, white grub is a big menace. So they attack the root of the growing seedlings, and the seedlings get dried up. For the control of white grubs, carbapenem at the rate of 12 kg per hectare, carbapenem 3G granules at the rate of 12 kg per hectare at the time of sowing on the furrows can apply. Then drenching of the soil with the imidacloprid, 70.8 SL at the rate of 300 ml per hectare, or the chlorpyrifos 20 EZ or quinalfos 25 EZ at the rate of 4 liter per hectare. Soil drenching can control white grub. Okay. Then shoot flies are another important pest which leads to the dead hearts. So spraying of 0.07% cypermethrin at 10 and 20 days after germination. If shoot fly eggs are seen, then it can control the fruit fly damage. But if you spray after the dead heads have formed, then there is only limited chance of saving the crop, because already the crop is fully damaged. So new tillers have to come from such plants. Okay. And the third, third important pests are the grasshoppers. So they defoliate. So in case of very severe attack, you can go for dusting the crop with 4% cypermethrin or fenvalerate dust the rate of 25 kg per hectare, or spray the crop with 0.07% cypermethrin. Okay. And stem borer is another important pest in case of all the millets like sorghum and pearl millet as well as the finger millet. So here also the symptoms are dead hearts, appearance of dead hearts. So go for carbapenem 3G granules applied on the whorls before flowering, 8 to 12 kg per hectare, or metacystox 2 ml per liter spray can also control the stem borer to some extent. So these are some of the important diseases and pests. So this is downy mildew. So the young seedlings, they get dried up, or if it attacks at the later stage, so the panicles gets converted into green ear. So that is why it is also called the green ear head disease. Okay. Then the blast, it is another important, gaining importance now, because previously only downy mildew was there, blast was not there. So now blast is also coming in a very severe proportion. Then rust is there, especially towards the maturity stage. Then some of the pests, white grub, as I already told, this is the grub on the left side, and this is the adult beetle. And these are the damaged seedlings of this white grub. Okay, so the entire seedling gets dried up. Then grasshoppers, they cause extensive defoliation. Then a gray weevil, and also the earhead bug, which sucks the sap from the developing grains, and it leads to chaffy grains, right? Okay, so to conclude, coming back to biofortification, so it offers a long-term, sustainable, food-based solution for elimination of micronutrient malnutrition. So it actually targets the resource-poor, micronutrient deficient people in the remote rural areas of developing countries, where other strategies like your fortification or supplementation cannot work. and it involves one-time investment to develop seeds that fortify themselves. Because I have not covered the process of development of biofortified varieties, because you may not be directly involved in that part. That is mainly for the scientists sitting in the different universities as well as the institutes. So that I have not covered, but it involves just like developing any other variety. So here also it is one-time investment. So once you develop a variety, so that variety seeds can be sold to different people, it can be shared with the different people, and hence they are sustainable as well as the recurring costs are less. So it requires a multidisciplinary research approach, because not only the breeders, even the nutrition scientists, they should get involved, the extension scientists, the economic scientists, and moreover, the government policy should be favorable. Nowadays, government is favoring a lot development of biofortified varieties, cultivation of biofortified varieties, but as such, there is no special price or premium price for the biofortified grains, because the grains are going along with other grains. So the farmers are not getting any special benefit if he is selling this produce. Okay, but if he consumes this himself, then definitely there will be improvement in the health. Okay, so it requires a multidisciplinary research approach and also the government support in terms of the policy interventions, and millet biofortification can be a feasible strategy, because significant genetic variability has been observed for iron and zinc content in all the millets like pearl millet or sorghum or even small millets, and other nutritional factors has been the variability has been detected. So you can manipulate the other nutritional factors also like a phytate or polyphenols, and it can be used in varietal development, so that you can develop biofortified varieties, and you can distribute it among the farmers, so that the farmers along with consumers get the benefit of increased nutrients in their grains, so that the health gets improved. Okay, so these are the biofortified varieties released. About 87 biofortified varieties has been released in different different crops like rice, wheat, maize. So as I told, ICAR has a separate program for biofortification in case of the cereal grains as well as millets, and also in some of the fruits and vegetables. Okay, so these are the varieties released in different crops: rice, wheat, maize, pearl millet, finger millet, millet, lentil, then groundnut, linseed, mustard, soybean, etc. So these are the traits input. Mainly it is a protein content, iron, zinc. These are the important traits. Then the calcium improvement, then the provitamin A, then lysine, tryptophan, etc. Many of the essential nutrients also, and some reduction like erucic acid in case of mustard. No, erucic acid in case of, I think, gossipol is a no, erucic acid in case of mustard. So reduction of erucic acid also is one of the breeding strategy to improve the quality of the mustard oil. And glucosinolates, this is another component in case of mustard. So reduction of glucosinolates.